Yes, hello friends, welcome to BISP Solutions. Myself Ashwin, and BISP Solutions is a tech company and provide technological solutions across the world. Now, so far in the last few days we have been learning about PyTorch, right? So today we are going to see something else. Yesterday also we see classification related, right? Decision tree. Now today I am going to show you linear regression. This is related to machine learning, right? Okay, so now today I am going to show you the linear regression on sales order data. See, all these regression techniques, these are useful if we apply them on business data. Our main target is to apply this intelligence, artificial intelligence, machine learning and deep learning, all these things related, they should be applied on business area. And once in this business area, when we apply these, it will add a value to the business. So that is our purpose. Only just learning what is regression, that is not resolve the purpose, right? So what I am going to do now, from now onwards, I will use the business data and I will show you how this business data can how this AI and this business data can be connected with each other, right? So that is our main target. So that is called adding value to the business. Otherwise just learning what is linear regression, that will not serve the purpose. Okay, now let's see here. Just give me a second, just a second. Okay, now let me make it full view. Okay, now linear regression on sales order data. Now see, linear regression on sales order data. See, suppose, just take an example. I am a businessman and I have opened one more plant. I have a factory of, like, just take cold drink factory, right? I have a plant of cold drink, manufacturing cold drinks, any type of cold drinks which are used in summer season when the temperature goes very high. Now I have opened a plant of manufacturing plant. Now in that case, based on the history, I will try to predict exactly how much it will be beneficial for me after opening the plant, right? So what we do, we take the historical data. We take historical data and on the basis of that we derive the future. This is just a prediction, right? So now today also I am giving you a similar example that I always used to give you. Suppose I am having school data, right? In that school data I have seen for the last 4 years, whatever, just take a real life example. For example, there is a data of a school in which the school is the pass out students. For example, within the last 4 years, like 300 students are passed out, but none of them are getting a very good college, right? So that depends that whatever the new students will enter in that school, same education will be given to those students. So the probability is that when whatever happens with the last passed out 4-year students, same thing will be given to those students. So now this is called this is our human intelligence. We predict by our own experience. But how it will be done? With the help of machine learning techniques. How it will be done? With the algorithms. That is our main target. Let's take one more example. For the last 5 years, let's take any metro city of any country, right? Now for the last 4 years, if I am having that whatever the profit is company is making, Now if I open the same plant in any other city, then what will be the chances that it will go in profit? So these type of things, that means wherever previously what happens, the predictions are done based on the done by the owner of the company, but now the criterias are different. The criterias are different. For example, previously what happens, I'm giving you one very best example. Previously what happens, suppose if a person opened a cold drink plant in a city, now all the crowd will go to the same cold drink, right? But now today the criteria is different. People are becoming health conscious also, so few percentage of the crowd is health conscious, so they will take care that whether they will choose for another option. So now in the market there are so many different types of cold drinks. One for diabetic patients cold drink, one for BP patients cold drink, so one for low calorie cold drink. So there are different criterias. So that is why nowadays it is difficult for a person to take care of each and everything. So now machine learning techniques, there is a very big algorithm working behind this linear regression, and on the basis of that algorithm, it derives that exactly whether you will get profit in this new plant or not. Okay, so now see, same thing is here. Agenda is how machine learning can be applied in an ERP. I have opened a plant. Now based on the people living in that particular city, based on the educated people, based on the health conscious people, so all these different criterias are there. Now this was just an example. Now we are working on transaction data. Same thing will be applied. For your easy understanding, I have taken the cold drink example, that's it. Now see, predictive analysis. What is predictive analysis? Predictive analysis. Machine learning algorithm can analyze historical data within ERP system to predict future trends, demands and outcomes. For instance, predicting inventory levels, sales forecast or equipment maintenance needs can optimize resource allocation and decision making. Now let me give you a step-by-step explanation on this. Now here it is written, for example, predicting inventory levels. Second, sales forecast. What will be the sales? Now suppose I am having a data of weather data, forecast data of last 4 years, and I am seeing that the temperature constantly going up every year by year. So definitely this year also, based on the rainfall data, we can predict that how much summer, how much temperature will go high. So based on that I can predict, I can say to my owner that okay, this year the sales will be good. The more the temperature goes high, the more the sales of cold drink will go high, right? Secondly, equipment maintenance. Now equipment maintenance also is the one more factor. When the machinery is used on at its very high level of what we say, the capacity, then definitely the equipment maintenance will also need frequent maintenance, right? So these are different how human does this based on the data. Same thing, we feed the data into the machine, and then machine also doing the same thing. The algorithm is written by humans, right? So definitely the algorithm will also predict based on this only, right? Now why we do this? Predictive analysis can be used to streamline operations, boost the revenue. Yeah, once the owner gets the accurate or approximate sales data, definitely he will take care of that. He will take necessary actions and mitigate risk of almost any business or industry, include banking, retail, utility, public sector, healthcare and manufacturing, right? Sometimes augmented analytics are used, which uses big data machine learning, right? So there are different techniques. Yesterday I explained you about the decision tree. This is a little bit same. It is quite easy than the decision tree. It is not that complex. Now see, introduction to machine learning and linear regression. Now machine learning is a subfield of artificial intelligence which is broadly defined as the capability of a machine to imitate intelligence human behavior. Now see, as in the beginning of this session I told you that I will take decision based on the historical data, that how much this cold drink plant will make profit. Same thing it is written here, that capability of a machine to imitate intelligent human behavior. Artificial intelligence systems are used to perform complex tasks as a way that is similar to how humans solve the problem, right? How I solve the resolve any problem, like for example, if my owner says that how much will be the profit, what's your thinking? So based on the historical temperature data, historical weather reports, I will say that okay, this year again the temperature will go high and definitely the crowd will demand for more cold drinks. And when our machinery is used, our vehicles are running for transportation, definitely again the maintenance will be increased, right? So all these things are connected with each other. Like in our daily life, if you see, when the petrol prices go high, then immediately the vegetable and fruit prices go high, because the transportation charge is added into that vegetable prices, right? So in this way, now linear regression is an algorithm that provides a linear relationship between independent variable. Just one second. Okay, independent variable, just one second, between the and the dependent variable to predict the outcome of future events. It is statistical method used in data science and machine learning for predictive analysis. Now what is this independent and dependent variable, right? Let me explain you that also. For example, my company has opened up cold drink plant in a city, metro city. Now what will happen? What are independent variables? Weather forecasting report, the people, the number of educated crowd in that particular city, where we are opening the stores of our cold drink. So wherever we are opening the stores of our cold drink, so what is the crowd, like educated crowd, or we can say the rich people crowd, whatever. For example, if I open a shop in a posh area, like where all the doctors and engineers are there, so the doctors, they are more conscious about their health, so definitely they will avoid that cold drink. But those which are engineer, or we can say, if I open a store, if my company opens a store in a like a hostel area where all the B students are living there and studying, so definitely the college students, they are not that much aware of the health, they will consume cold drink. So in this way, independent variable means independent data which already exist. That means if I am standing in a city, or a colony, so whatever the data that already exists, that is called independent variable. Number of people living there, the crowd, the number of educated people, the number of uneducated people, these are called the independent variables. Dependent variable means the profit. See, the profit what we are going to derive, that is a dependent, and this profit is derived or calculated based on this independent variables, that is number of people, the area in which what type of people live, they are already existing, right? So this is called, so it's not a very difficult thing to understand. Okay, outcome of future events, right? It is a statistical method used in data science. Now in statistical modeling, regression analysis is used to estimate the relationships between two or more variables. That is, now there are two types of regression, single and multi-regression. Now today I am explaining you linear regression. I will explain you the multi-regression also in our upcoming sessions. Now dependent variables, also known as criteria variables is the main factor you are trying to understand the and predict. Dependent, that is what I am saying. Profit variable is the dependent variable. Independent variable, also known as explanatory variables or predictors, are the factors that might influence the dependent variable. That means the data which already exists. Simple linear regression is a method we can use to understand the relationship between an explanatory variable x and the response variable y. Okay, now just now I will show you the practical part. Clear? Now see here, first of all I will create a blank IPyNup file, that is interactive Python notebook, IPyNup interactive practical notebook. So linear regression, let's wait for 2 seconds. Yes, first of all change the name. This IPYNB means interactive Python notebook. Okay, now linear regression underscore bootcamp, right? Enter. Okay, now this is created. Secondly, I have already created this financial CSV. Now what is this financial CSV? Let me explain you this. Now look at this financial CSV. Exactly what happens here. Segment, country, item name. Actually this is a financial data, sales data, total revenue, profit, month number and the year. This is the sales data, transaction data, correct? And this is what we are going to do this. So let's start our here. Now see, I have already today I will show you everything running, right? Now first of all what I need to do, see where does this data Excel sheet comes from. See, I have opened my ERP, the NetSuite, and then that NetSuite gives me the data of the transaction, right? Whatever the transaction or the sales order data, in general language we can call it as sales order data, and right. So I have extracted the sales order data from the NetSuite, right? And that NetSuite provided me data. Actually it gives you so many rows and so many columns, but for our now it is up to us that what type of columns that we needed, right? Suppose if I give you an Excel sheet in which student's name, father's name, okay, mother's name, okay, residence area, okay, student name, okay, father's profession, okay, neighbor's name, and how much his father, how many brothers his fathers have. These are unnecessary information, so you can remove those also, right? So same thing is here. I have taken the Excel sheet of the NetSuite and then I have removed all the unnecessary data, so limited data is remaining now. Okay, now let's work on some practical. It is very easy to understand. You will easily understand this. Now see, our first task is the very most common and popular library, that is pandas library, numpy for mathematical calculation, import math, right? Because we have to apply some mathematics also in that. Import matplotlib.pyplot as plt, right? So all these libraries are to be imported first. It is just like programming, like in other programming languages. First you have to import the libraries, that's it. Enter. Now it is importing all the necessary libraries in this Jupyter notebook, right? So we need to wait for 2 seconds. After that, what we need to do, we need to import that Excel sheet, right? So look at this, financial data pd.read csv, and this is the complete path. Here is the financials.csv, right? and here the financial data. Now suppose, now look at this, here 436 rows are there, it included this header also, right? Now segment, country, item name, item price, total revenue, profit, and month number, and everything here like this. Now it has extracted all this data, but there is one more thing, that is the linear regression techniques does not work on alphabetical order, alphabetical data. Right now we humans, we can see, okay, this is the name of the city and all these things, but the machine does not understand what is France, what is Canada, what is Germany. It understands the language of numbers, that's it. So we need to convert all the alphabetical data into the numbers. That is our main target now, right? So how do we do this? There is one more function, that is dummies. Now I also recommend you to, whenever get time, see the pandas comments also, commands, pandas commands. There are hardly 20 to 25 commands are there which are very frequently used, very frequently. So I recommend you to watch some pandas videos also. I have already prepared some pandas video. So if you search on net, you will easily get that pandas videos. Now see, financial data equal to pd.get dummies fin data. Fin data means that's a data frame. Data type int. Now see, get dummies fin data, take data frame fin data and convert it into int. That's it. I have not given what to take for Germany and what to take for Mexico, nothing, right? Now look at this, converted, everything is converted. It increases the number of columns, right? It increases the number of columns. Okay, so this is the first task. Secondly, now again the same thing, this is the complete combined data. Now this complete combined data should be broken into two parts. One variable is for all the independent data and one variable is for the dependent data. See, in human, where the human thinks, we also think like this only, but we don't observe all these things in depth. Suppose if I have to tell my owner that how much benefits, how much profit will your newly opened plant will gain. So what, in the back end of my mind will fetch the data in a separate variable and calculate the profit in a separate variable. Same thing is done in the programming language. Our mind is also thinks like this only. We keep, but that is internally and it is done by neurons. So normally we don't observe all these things. But to convert that data into the programming language, we have to do this. The variables are taken, right? Now see here, x and y variables are there. Now what we have done, we have taken all the item price, total revenue, month number, year, segment, channel, everything is taken in x variable, and remaining all the dependent data, that is the profit, it is taken into the y variable. Fine. Now what next? Now once you have taken separated the data into different variables, now one more library come into role, one more thing come into role, that comes here. Let me do this. Okay, from sklearn.model selection import train test split. Actually it's a library train test split. This train test split, what it will do, it will split the data into the training data and the testing data. That means in x variable whatever the data, so 80% of that x variable data will be converted into train data and remaining 20% will be converted into the test data. Similarly, when y variable, whatever the data into the y variable, that is the dependent data, 80% of that data is converted into the train data and 20% will be taken as a test data. So that is why 4 variables we are having: x train, x test. X train the 80%, x test the remaining 20%. Y train is the 80%, y test is the remaining 20%. Okay, here this 2 denotes the 20%. That means test size is 20%. Random state 51 means every time it does not shuffles the data. Like for example, if you might have worked in the Excel sheet, in that Excel sheet RAND, there is one more there is command RAND, and if you put 2 to 10, so the random numbers will be selected within that, the random numbers will be written within that given cell. And again, if you refresh that, if you go to the that particular cell and hit the enter button, again immediately the number changed. So same thing happens here also, and in that case random state 51, if you put like this, then the data will not shuffle, data will not be changed, same data will be used. Okay, so now what I am doing here, now sklearn model train test x train, x test, y train, y test, right? So let's wait for 2-3 seconds, I will show you. Now see here, 348 means x train means 80% of the data. 20, that is the 20 means the 20%, that is this is the x test. Similarly, y train means 88 of the whatever the data. 20 means the y test, right? Y train, y test. Okay, now I will show you one more thing. Okay, from sklearn model linear regression, now let's talk about the linear regression. Now see here, 80-20 is divided, fine. Now from sklearn linear model import linear regression. Now linear regression is already a pre-ready-made library. Linear regression, LR is a variable linear regression, that means one instance is created of that particular library linear regression, and that is called the LR because we need one variable also. LR.fit what? X train, y train. That means the training data is fitted into the linear regression instance. LR.score, x test, y test. Now look at this, score means it shows that 77% is the accuracy. Clear? Now see here we have got the accuracy. Now see linear regression, ypred is a variable, and we are going to now predict. Now the real game begins here. y_pred equal to lr.predict. With the help of function predict x test, we have put the x test data. Already we have put the x train data into the lr.fit. See here, that means the training data is already fed to this particular library. Now we are giving the x test, that means for testing purpose. Training is done, now the test data prediction underscore data frame equal to pd.data frame, actual value is y test, predicted value is ypred, and the difference is test minus ypred, so predictive df. Now see here, this is the actual and this is the predicted value, that is 66. And this is the difference between these two actual and predicted values. Now if you ignore this first row, you will see here 17, this is 15, 11, this is 11.75, then you will see here 1175, here you will see 37, this is 53, 20, 21, right, 92, 85. That means almost there is a very less difference. If you see, they are very close, the difference is very less, not so high. For example, if you see this 11,135, 11,759, that means within the same range, 11,000 to 12,000, during that particular range, right? So during that particular range, the data difference is there. Now if you see here, the final is linear regression. Okay, now see, linear regression imports seaborne as SNS. It's a scattered map. Seaborne as SNS. Seaborne is a library in which we are calling that Seaborne library. Already all these libraries you have to install, right? And for installation, pip install, that particular library name is used. You can see my previously created videos also. Okay, now import seaborne as SNS. So SNS.reg plot x equal to y test, y equal to y predict. That means on x axis y test data will be there, and on y axis y prediction data is there, right? Then scatter, it's a scattered chart, so that is why we have written here line KWS. I'll go color is red. Okay, now I'm going to hit this enter button. Now see what happens here. Now see, if you see here, this is the profit, this is the blue color, and red color is the predicted. Red color is the predicted line, blue color is the original sale, and you can see here there is a too much difference, this two blue dots. As I already told you, it's a prediction, right? It's prediction, not a 100% guarantee, right? Not 100% forecast that only this will happen. This is just a prediction, and for this there are some if any error comes, then in that case there is one more technique, random forest technique, that is that works differently, right? So in our next session we will see the random forest technique of prediction. And as far as this linear regression, it's very quite simple. Let's have again quick recap so that you will be just a second. Let's take a quick recap first. Just a second. Okay. Now see here again, let's have a quick recap. First of all, what we have done, we have to import the libraries, then we have to import the CSV file, then we have to convert the alphabetical data into the numerical data, right? And then after that numerical, we split the data into two variables, that is one dependent, that is another independent. Then we import the function that is train test split. library, right? And after that linear regression what we say the library is called, and we fit the data and we test the data, that is whatever the testing is done, so it gives you 77% the accuracy. Then you see here y prediction equal, that is linear regression. So we are doing the linear regression on them and we see whatever the predicted versus the actual value, right? And the we see the difference of between them, right? Then we will see here after that, with the help of a seaborne library, that is for scatter the chart, so it we just put the data inside it, and based on the data it gives you that type of value. Right? So this is how the linear regression works, and you can use it on any type of data. You can easily get the data from any company if you have data that is well and good. Otherwise you can get the trial data also on very easily to practice this. And so my suggestion is to just watch this video twice, thrice, and because whenever a new thing is there we need to put some efforts. So watch this video twice, thrice, and you will get the clarity, and whatever the doubts that you are having, you can put it into the comment box. I will resolve them, right? So guys, today we are concluding here only, and tomorrow we will see some other topic, right? And if you face any difficulty while practicing this, you can put it into the comment box. Okay guys, let's meet in our next session with some new topics, right? Thank you for watching, attending the bootcamp.